Good day, Math 30-2s. Today we are continuing our Chapter 4 Rational Expressions and Equations unit. Today talking about simplifying rational expressions. Simplifying. So simplifying often is associated with making things simpler or smaller. Now the point of today is to cancel fractions to make the values smaller, and there's such trickiness in simplifying rational expressions that we want to be extra cautious. Can any one of these 6 statements be made more simple? Now you might think about BEDMAS as you do these and say, well, 7 plus 7 is a 14, and 14 divided by 7 is a 2. And that's actually very, very true. A deceptive part of this first one is to say, oh, well, there's a 7 on the top and a 7 on the bottom. Don't those just cancel? That actually doesn't quite work. If we know the answer is supposed to be 2 because 14 divided by 7 is 2, then what happens if these cancel? Is this just gone and you're left with a 7? That's not 2. If these cancel, are you left with a 1? 1 plus 7 is an 8. That's not 2. There's something happening here. How about this next one? 7 plus 1? Well, that's an 8 divided by 7 if you just follow BEDMAS rules. Add that top together and then make sure that top divides by the 7. But could this cancel? This definitely could cancel, but I know it's 8 divided by 7, but if I cancel those, is it 1 plus 1 is 2? Well, that doesn't seem to work. This definitely became more simple. This can become more simple, but not really by canceling. I could tidy it up a little bit though, but not really simple. X plus 3 over x. I'm a little nervous now about canceling x's. And even in this case, I'm getting a little bit nervous about when I can cancel and when I can't. I know that 7 times 7 is a 49 divided by 7, which is a 7, and all of a sudden if I cancel those, that matches. How come I could cancel those ones, and above I said I couldn't? Can I just cancel those and say 7 times 1 is a 7 divided by 7 is a 1? That seems to work. There seems to be a little bit of risk in canceling top and bottom, but there is something about addition and multiplication that changes everything. I have a little bit of a rule to talk about when a fraction may cancel, and this is if and only if there is an identical value on the top that is also in the bottom. There's a 7 on the top, there's a 7 on the bottom. There's a 7 on the top, there's a 7 on the bottom. Something might get to cancel, one of those 7s. You can only cancel if this value multiplies by the rest of the numerator or denominator. So this 7 down here was multiplying by that 7. Because it was multiplying, we're able to cancel. This 7 that I want to cancel was adding with the 7, and that's the problem. We can only cancel if what we want to cancel multiplies by the rest of the numerator or denominator. So I see a 3x that matches with a 3x. Can I cancel it? Well, because those 3x's are both multiplying by the remaining parts of their top and bottom, you bet. Hey, I also see a matching x and x. Do those x's get to cancel? Well, this x is subtracting with a 2, so no, it has to be multiplying. Does not get to cancel. Here's a 3x, here's a 3x. Is it multiplying by the rest of your top or bottom? Well, this 3x is adding with the 2, so no, it doesn't get to cancel. A deceptive part of this is if you see a 3 and a 3 and you're saying, well, the 3 multiplies by the x and the 3 multiplies by the x. Well, that's true. It's not multiplying by the rest of the numerator or denominator. You would have to see this 3 times all of the denominator to be able to cancel a 3 and a 3. So in fact, nothing gets to cancel. This one could, this one could not. This one looks like the 3x is adding with the 6x squared, and this 3x is again multiplying by the remaining part, which is a 1. And you'd say, well, I want to cancel the 3x and 3x, but it's adding, so you might say nothing gets to cancel. But a very first step that we're always going to talk about is, if possible, factor. I'm going to factor out the top. And I notice that a 3x is common to both terms in the top. And if I factor out a 3x, I'm left with a 1, because 3x times 1 is 3x. 3 times 2 gets me the 6. X times x gets me the x squared. And I can factor out a 3x. I've actually created a product on the top by factoring. And in doing so, the 3x is multiplying by the rest of the top, and it can actually cancel with the 3x that's multiplying by the rest of the bottom, which is just a 1. So there is a way to cancel, but it was secretly hiding and quite deceptive. So a good thing to consider is, can I factor before you do any question? So reduce or simplify the following fractions by creating a matching term through factoring. So factoring is breaking a number up into a product. Now you might look at this and say, oh, I can divide by 2, I can divide by 2, I can make this simpler. Just to show you what we're doing, why we're doing it, I'm going to break 4 into its 2 factors, 2 by 2. A 10 I'm going to break into a 2 by 5. It's still factoring, but it's breaking it into 2 numbers. I can now see that both of those 2's are multiplying by the rest of their terms, and we're going to cancel. So now we're left with a 2 over 5. And we could have got there as well by saying 4 divided by 2 is 2. 10 divided by 2 is 5. We can break this into a 3 times an x by an x, because that's what x squared is, x times x. This is a 2 by 3 by x by x by x. And we can cancel whatever we see that matches. X, the 3's, the x's, we're still left with this x on the bottom and this 2 that's on the bottom. They are in fact still on the bottom. Don't move those up to the top. And the last one, you can factor out a 3x, left with a 1 plus a 2x over a 3x. 3x's cancel, and you're in fact left with a 1 plus a 2x. Now there are some x's that are left over, and one of the things that I need us to come back to is a reminder that if you cancel a variable, a non-permissible value must be stated based on an original expression. So even though I got rid of a denominator in this question, based on the original, I was not allowed to use x equals 0 up here. All of a sudden, hey, there's no denominator. Maybe x is 0 is okay. Based on the way the question's originally worded, x cannot be 0, and that sticks through regardless of what kind of work we do. So I do need to make a statement that says, you know what, x still cannot be a 0. We're welcome to still say x cannot be 0 for number 2, but it's still, I'm going to say obvious that you can't put a 0 on the bottom because there's an x that's on the bottom. So there are some that you can try, and we'll move on to example 3. Reduce the following fractions by creating a matching term through factoring. These top ones were monomial denominator, monomial denominator, monomial denominator. This time I've got binomials to ramp things up. Now we can actually factor a 2 out of the top, leaving us with an x minus a 2. And again, I am moving a bit quick through the factoring now. We can take a 2 out of the bottom, leaving us with a 2x minus a 5. And what I do see is a pair of 2's that are multiplying by the rest of their sides. And I see an x and an x, but this x is subtracting, that x is multiplying by the 2, but then that's subtracting, so there's some adding, subtracting happening, and we're sort of stuck at that point. Final answer. Now I could again state the non-permissible value, but it's still, it hasn't been canceled out, so I'll leave this as it is. For number 2, it looks like this x minus 1 is very different than a 1 minus x, even though they look kind of similar. This one is actually written into an exemplar or a sample question from Alberta Education in their program of studies. And this one's kind of tricky because you can actually factor something out that will make things match a little bit. This is a positive x on the top and a negative x on the bottom. It's a negative 1 on the top and it's a positive 1 on the bottom. It's like they're the opposite sign. I'm going to actually factor a negative 1 out of the bottom, and that's going to change the sign of the denominator. Now it's going to be a negative 1 plus an x. And if we reorganize that bottom, a negative 1 plus an x is a positive x and a subtracting 1. X minus 1, x minus 1, those entire binomials are the same. See this bracket that is kind of not necessary? Those are identical. So this whole expression is actually just a negative 1. And lastly, we've canceled out the coefficients that resulted in the front. We've canceled out binomials here. And in this last one, we're going to factor out a 3m, leaving us with an m minus a 2. We're going to factor out a 2m, leaving us with an m minus 2. And not only can these binomials m minus 2 cancel, also these m's can cancel. In this case, we're left with a 3 over 2. A good question to dialogue with someone is, do we need to state a non-permissible value now? Is m allowed to be anything? Is there even an m? As a reminder, are we stating those non-permissible values when we cancel variables? Be sure you state restrictions if you cancel out some letters. Here are some to try, and a good challenge one. And that actually ends lesson 4.2. And in the next one, we're going to be looking at multiplying and dividing rational expressions in 4.3.